thermoforming, injection molding. Aerospace always have this misconception that I don't think we need those technologies because we don't have the rate. Next 20 years, we need to build about 40,000 airplanes. That's about a 4 to 6 times increase in rate. This is a window plug for 777, 30% lighter, less than half the price, and 80 times faster compared to a metallic plug.
The NIAR is a research center in the United States. We have quite some unique capability, especially in composites. The director tells us a little bit more about how they made a thermoplastic composite window plug for the 777. Check it out. Waruna, thank you very much for giving your time. Tell us a little bit more. I can see some thermoplastic parts.
Right.
Here.
So I'm with the NIAR, or National Institute for Aviation Research at Wichita State University. I'm the director of NIAR ATLAS. ATLAS stands for Advanced Technologies Lab for Aerospace Systems.
Okay.
It's a new lab. It's about 6 years old, and it's set up to create a maker space in the United States for advanced manufacturing. If you go back 6-7 years, even larger companies had to go to Europe in order to do some of the thermoplastic research work. So we created the maker space in the United States, so even a small or a medium-sized company has access to the same technologies that the large companies have, especially when it comes to automation and thermoplastic research. Especially if you think about automated fiber placement, thermoplastics, typically require laser. They use hot gas as well, but laser is more accurate.
It is more,
It becomes very costly, the equipment, the infrastructure, you have to have laser enclosures and things like that. So not every company can afford to have those kind of technologies. So the idea of the makerspace is, if you have an idea, you come and you make it a reality, and then you go to your funding agencies.
Quick pause on European research institutions. Now, in Europe, there's a big network of government-funded research institutions that tend to work very well collaboratively with each other. So what it means is, if you're a small to large company and you're curious about some very unique capability, what you can do is you can go into one of these research institutions and do some R&D and figure out, is a process or some very unique equipment the right thing for you? And if it is, then you can go and purchase that kind of equipment. But really, it lowers that barrier to entry before you do the investment for big capex. The United States has not had that up until recently, and pretty much that is what the NIAR is doing. So this idea is we've seen it a lot in Europe, right? So you get the DLR Institute and all of that.
Right.
We haven't seen it that much in the United States. How comes it's not a thing, but obviously it's happening now?
7-8 years ago, you go back, it was actually the CEO of Spirit AeroSystems. He was talking about that we have 26,000 airplanes built around, around the world, last 50-60 years. Next 20 years, we need to build about 40,000 airplanes. So that's, if you look at that, that's about a 4 to 6 time increase in rate. So even if you double the size of your factory, you're not going to be able to find enough trained technicians to build aircraft parts. So this is on top of the UAV and the eVTOL demand. This is just the commercial. So we wanted to get into automation, do actually 3 things. First, being part of a university, we want to create a workforce education program for high, technologies like, automated fiber placement, thermoforming, being able to process thermoplastic. Not everybody does those things, right? So create a workforce development for the future. And also work with the industry to solve their today's problem. Like maybe you have a thermoset design, you want to go to thermoplastics because you want to increase the rate.
The barrier to entry is also high, right?
Right, exactly. And demystify the automation. People always think, oh, the automation costs money. I have to have so much rate. So if you think about the cost, what you're looking at is the automotive mature technologies, thermoforming, injection molding, right? But the aerospace always have this this misconception that I don't think we need those technologies because we don't have the rates. But rate is not everything. The cost and the time also a big component. So like for example, this is a window plug for 777.
Yeah.
And normally when you convert a passenger aircraft into a cargo, you take the acrylic window, which is heavy and maintenance nightmare, and you take the acrylic window and replace it with a metal plug.
Okay.
Right? So I'm guessing it probably take an hour, 2 hours to machine the metal plug. You start with a billet and you probably waste about 60...
The buy to fly is very hard.
Right, 60-80% of them.
Easily 80, yeah.
Right. So, and we reverse engineer that and created this thermoplastic window plug, which is about 30% lighter, less than half the price, and 80 times faster compared to a metallic plug. So it's cheaper, faster, and lighter. But then, when I give those numbers and people say, well, what about the $200,000-$300,000 tool? So if I save $200 per window plug, very conservative, you can save a lot more than that.
Yeah.
If I save $200 a window plug, if I can make 400 of them in a day, that 8-hour shift, that's $80,000 saving in one day. Yeah. And we also design the mold such a way I can use the same, most of the mold, the expensive part of the mold, not just for 777, it could be a 737 window, it could be a 350 window, it could be an access panel.
Yeah. Waruna makes a really good point here. So generally speaking, when you want to go and you want to manufacture some thermoplastic composites, one of the challenges that you have is you make a tool for something and it's usually quite expensive. And you want to make a different variant. What it means is you have to reinvest that cost of tooling. But they've done something quite clever. And if you look at the video, you will see it looks like the cavity of the tool might be removable, therefore interchangeable. What it means is you paid for the bulk of the tool to be manufactured. And now you want to do a different variant. So instead of the 777, you can go into the 737, whatever it is. You can just change the insert of that tool and put a new insert into exactly the same tool. So that expensive tool can be used to make many different parts, and pretty much changing the inserts is a lot cheaper.
We exist to show the art of the possible, demystify this fear of automation and things like that. So
absolutely, yeah. And I can see you have quite a few parts here. One is the access window. This part one was only a taster of what NIAR is doing. In the next video, I will be showing you what is, in my opinion, one of the most complex overmolded parts that I've ever seen. It is incredible. I am talking about overmolding, forming, and the addition of continuous fiber ribs, which makes a part which is truly one of the most complex three-dimensional thermoplastic parts I've ever seen. If you like what you've seen today, click on the subscribe button. It really helps to grow the channel, and I will see you soon. Peace.